application to it.
Yeah,
And
Right.
it's not just like doing the same thing over and over again.
Right.
Surface area.
So questions.
Oh, no.
Number 9.
Oh, yes.
I got half of what the answer actually was. Or, I mean, the answer was.
So your answer was half of the value that they got?
Yes.
Okay. You didn't get half of the answer. Words are hard.
It's because you don't use one side.
So a rectangular plot of farmland will be bounded on one side by a river and on the other 3 sides by a single-strand electric fence. With 800 meters of wire at your disposal, what is the largest area you can enclose and what are its dimensions? All right. So this is actually one of those problems that I think I'm half convinced that Newton wrote a problem like this, and they've been in every calculus book ever since.
Biased.
Could be. So we've got our river on one side, and then we've got our rectangular fencing, right?
I think I already see what I did wrong.
What did you do wrong?
If it's, well, is it all 4 sides or is it just 3?
Pardon?
It's just 3 sides?
The river is one of the sides.
Never mind, keep going.
Okay. So what did you call this distance?
W.
Okay. And this?
No.
Okay. So we're trying to maximize the area, right? A is equal to W times L. I like doing it that way because it makes students go, what times? Oh, yeah. All right, but we've got 2 unknowns here. So we need an auxiliary equation or a secondary equation. What do you have for that?
P equals 2W plus 2L.
That what equals?
P.
Okay.
Is that
But I'm not going to put wire up on all 4 sides. I'm only going to put wire on these 3 sides.
just be W plus 2L?
Yeah, W plus 2L is equal to 800.
That's where I messed up then.
Okay,
So I did 2W plus 2L instead.
gotcha. Oh, so you found it was a square.
Yeah.
Yeah. Do you want me to continue or?
No, it's fine.
Okay. Anyone else want this one continued?
No.
Okay.
Can you do number 16?
Maybe. What are the dimensions of the lightest open-top cylindrical? Let me try that again. Take 2. What are the dimensions of the lightest open-top right circular cylindrical can that will hold a volume of 1,000 cubic centimeters? Compare the result here with the result in example 4. Okie dokie. So we need a little space here. So assuming the can is all made out of the same material, then the amount of material that we need, helps if we don't write on white, would be pi r squared plus 2 pi r h, right?
Yes.
I like the dramatic pause.
I don't like yes.
Yes. All right. And again, we have 2 different variables here. So the volume, 1,000, is going to be equal to pi r squared times h. So we can either solve that for h or we can solve it for r. Again, I think it's easier if you solve it for h. So 1,000 over pi r squared is h. So far, so good?
Yes.
Did you do it the same way?
Somehow didn't come up with the material equation. I don't know. I was doing this late at night, and I had 1,000 equals pi r squared times h, but I didn't have that equation.
So what you're having to do is, if you want it to be as light as possible, then you need as little material as possible, to make it. So yeah, you have the secondary equation, but not the primary equation.
Yes.
Okay. Do you want me to continue?
No, that's okay.
Okay.
Okay, explain for the M real quick.
I'm sorry.
Can you explain for the letter M?
Yes. So how we got this equation? So this is a cylinder that doesn't have a top.
Oh, that makes sense.
So we've got this plus the lateral area. All right, what other questions do you have?
Number 13.
13, all right. Design a poster. Sounds interesting. You're designing a rectangular poster to contain 50 square inches of printing with a 4-inch margin at the top and bottom and a 2-inch margin at each side. What overall dimensions will minimize the amount of paper used? Oh, that sounds interesting. And there's several different ways you can set this up. And I'll be honest, I don't remember which way works best. So we'll just do it and see if it works well. So I'm going to draw a quick picture of this. Typically we have pieces of paper that look like that. Then on the inside there's going to be a part that's filled in. And it'll look something like that, right? So did you give variables for the dimensions of the paper, or did you give your variables as dimensions for the writing?
I did it for the paper.
Okay. So what did you call this?
X and Y.
Okay. And so you want to minimize the area of that piece of paper, right? All right. And then for your secondary equation, what did you have?
Sounds like, and then. Oh no, sorry. I did it for the inside part. Wait, when it says 50, is that talking about the filled-in square?
Yes.
50? Oh, that's where I messed up because I had the entire paper was 50.
Oh, no.
Not just the print. Yeah.
It has 50 square inches of printing.
Yes, that's where I messed up. I made the entire thing 50.
Gotcha. Let's go ahead and continue this one, though.
Okay.
So, given that, and that these are 2-inch margins on either side, this dimension down here will be x minus 4. And then this dimension will be, because it's 4-inch margins top and bottom, will be y minus 8. So then we know for our secondary equation that x minus 4 times y minus 8 has to be equal to 500. Or 50, excuse me, not 500. Okay? And I think this is why doing it the opposite way works better, because this is a little ucky in terms of solving. It's not terrible. The thing that people do wrong on this is they distribute it, and then now you've got x in 2 different places.
Yeah.
It's better if you go x minus 4 is equal to 50 over y minus 8. So x is equal to 50 over y minus 8 plus 4. Then we can substitute that into this equation. So it'd be 50 over y minus 8 plus 4 times y. So that's 50y over y minus 8 plus 4y. And now we have our equation all in terms of a single variable. I think you can see pretty readily that that's going to be a little ugly in solving. I've seen worse hurt get well by morning. So let's go ahead and we have time today. Let's go ahead and go through this. So dA dy. So here we would have to use the quotient rule. So y minus 8 times 50 plus 50y times 1 all over y minus 8 quantity squared plus 4, we want to set that equal to 0. And at that point, you would just grab your calculator and chuff that into it. I'm curious, if we do it the other way, is it quite as nasty a derivative to set equal to 0? It's not nearly as bad? Because making the secondary equation the simpler one makes solving for one of those variables easier, right? So now I'm really, really curious. All right, so, gosh, that's ugly. Turn off the stat plots again. Substitute in x minus 8 times 50 minus 50x. Oh, no, plus 50x, not minus 50x. It's like, that can't be right. No, that should be minus. My fault. Oh, that simplifies a lot, doesn't it?
Yeah.
This is supposed to be minus. So that simplifies to negative 400 over y minus 8 squared plus 4 equals 0. That's a heck of a lot easier. And for my window on that, let's see, I want it to have 50 square inches of printing. I mean, I suppose it could be, 50 inches tall and an inch wide. I'll go from -1 to, I don't think it'll be beyond halfway, 25. And it turns out that that is at 1, 2, 3, 4, but somewhere between 30 and 40. Oh, between 3 and 4. Really? Really? Stop it. Oh, I went to 25. Man, I'm being stupid. You ever have days like that?
Every day.
5, 10, 15. So it's somewhere between 15 and 20. It's at exactly 18?
Yep.
Yep.
Yes, sir.
Interesting. And then we could find x, which would be 9. So if we do it the other way, I think it's going to come out to be quite a bit nicer. So we're going to have our piece of paper, we're going to have our printing, or it looks sort of like that. So if we make this x and this y, then this would be x plus 4 and this would be y plus 8. Then our secondary equation would be just xy is equal to 50, which is much nicer to simplify.
That way.
Okay?
No, never mind. I'm sorry.
Okay, sorry, I just heard you say something. I didn't know what it was.
I said that that's easier.
Oh yeah, much easier. Pretty much anytime you can make the secondary equation easy to solve for one of the variables, that's kind of the way you ought to trend. Because taking the derivative, unless it's a horrid function, is not going to be too bad. So we want to minimize the area, which is x plus 4 times y plus 8, where x is 50 over y. And I think this is even going to be nice once we distribute it. Because when we multiply that out, we'll have 50 over y times y is just 50, plus 400y to the negative 1, plus 4y plus 32. Oh, yeah. Easy peasy lemon squeezy. Right? The derivative there is going to be so much nicer. So negative 400y to the negative 2 plus 4. Set that equal to 0. We'll have 400 over y squared is equal to 4. But we got y was 18 last time. Oh, because this is 18. I was like, why is this not coming out to be the same? It's because the variable's in a different spot. So yeah, you get y is equal to 10. So this distance is 10. So my piece of paper is 18. Much nicer. And honestly, frequently you don't know which way is going to be better until you do it. But I tend to try and make my secondary equation simple whenever possible. Okay, what other questions do you have? Okay. Then let me hand back your quizzes.
We will go over those. I guess I'm the longest this time.
I like the bottom plane.
Not necessarily. Oh, that's right. Lynn has my key still. Are there any that you have questions about? Yes, Brett.
What's an appropriate explanation for number 4?
Same.
Yeah, I got all kinds of crap explanations on number 4. I got a couple of really good ones. So the correct answer, and I think most people figured it out, was B. Okay. Which of the following could be false? There are a couple of ways you can explain it. One of them is to say, well, if f is a linear function, joining the points -2, -5, and 1, 4, then f is continuous on the closed interval from -2 to 1, and differentiable on the open interval from -2 to 1, but f prime will never be equal to 0 on the interval from -2 to 1. So that's giving a counterexample. Right? They're saying it must do this. Well, here's a way that it doesn't have to. Now, if you want to say it more generally, and I think Maddie did this, if you want to say it more generally, you can say just because a function is continuous on a closed interval and differentiable on an open interval between 2 points does not mean that it has to have any critical points. And if it doesn't have any critical points, then there won't be any places where the derivative will be equal to 0. So that's the more general case. Most people try to do it with something with, well, it could be a line.
Which is what I did.
Which is the right way to go. I think that's the easier way to do it. You go, oh, well, what if it was a line? But you have to, say all the things.
I get that a lot from my English teachers. That's why I was upset. Or I don't say no.
Gotcha. And the other way you could do is you could go through and explain why A, C, D, and E are all correct. If you really want to, but I don't know why you would want to. Wait, was yours the one that was the diagram?
Yeah.
I'm like, yeah, it's a nice diagram. That's not an explanation.
Then do we have a solution that you can only minus 5 points because of my graph?
It was 25 points. The fact that it was only 5 points was quite kind of me. Any other questions?
I got never see it wrong, but
Okay, let's take a look.
Confusing that time.
Okay, well, let's take a look.
I didn't really understand the question.
Well, considering it's exactly like some of the ones that we did,
Yeah, but I don't know why I just forgot that they're equal to each other.
this is the mean value theorem, which states that if you have, find the coordinates, if any, in the interval from 3 to 7, at which the average rate of change of natural log of x minus 2, which is continuous and differentiable on this interval. It doesn't tell you that, but we know that it is, because natural log is defined as long as the argument is greater than 0. If you're starting at x is 3 and ending at x is 7, that's going to be true. So the average rate of change,
That's a mean value set.
well, the average rate of change is just going to be y at 7 minus y at 3 over 7 minus 3. Y at 7 is the natural log of 5. Y at 3 is the natural log of 1, which is 0. So I don't even need to write that, over 4. That's the average rate of change. The instantaneous rate of change of the function is simply its derivative, 1 over x minus 2. All we need to do is, it says find the x-coordinates, if any, at which the average rate of change is equal to the instantaneous rate of change. So now we just need to set them equal. I personally would take the reciprocal of both sides. And I wouldn't even whip out a calculator for this. I would just leave it.
Got it.
If this was a free response or part of a free response question, it would probably say something like, must there be a point? And if so, find it. And if not, explain why not. All right, anything else?
Oh, I got a general question.
General question.
So on the arrow meanwhile theorem questions, we have to say that we have to write the sentence of the science. It is a continuous in a closed interval. And
If you're going to apply the mean value theorem to a problem, you must state that it fits the prerequisites for that theorem, which is that the function has to be continuous on the closed interval and differentiable on the open interval. Yeah, anytime you're going to use that and it says justify, you have to say that.
Thank you.
Certainly.
May I
Yes,
use the
ma'am.
restroom?
You may. All right. Well, you can then